This is the 20sim tutorial for ME560. I'm going to get you started with the basics of 20sim. So the first thing to do is to find a computer with 20sim on it. There are a bunch on North Campus. You can also use remote login if you want to use your laptop or work from home. So the system we're going to focus on is this guy here. It's got a bunch of springs, a damper, a mass, and we're going to work out this bond graph in 20sim, and then we're going to simulate it. So now let's bring up 20sim. First thing you'll want to do is go to this left pane and make sure you're on library here. Then go to library, bond graph, and you'll have a bunch of basic bond graph elements here. So if we just grab and click and drag the bond graph elements out here like this, we can make our bond graph look like the one that's in the handout. So this inertia will be our mass. We'll grab two capacitors for springs, like this. And then we'll get a resistor for the damper. And we'll zoom in a little bit. So now we can just arrange these neatly. How they're arranged doesn't actually affect the program, obviously, but it affects how nice things look. And given that bond graphs tend to look like spaghetti pretty quickly, it's good to try to organize them. So here we are. Now we need to connect everything up. So to do that, we're going to go to this connect tool here. You can also just press spacebar and toggle to the connect tool. So as everything's connected up, we start with the base and then go to the head for each arrow. And 20sim will automatically assign causality. Right now there's derivative causality, that's why this is orange. And we can just keep working through this. So now we already have our bond graph up and going in 20sim, but we should rename everything so that we can reference things properly later. So that'll happen a lot. If you double click on things, you'll get this little code screen that you don't need to use. You can just hit go up. What you want to do is right click and go to properties, and then you can change the name. I'm going to change it to F for force. I'm going to change this one to M for mass. This is our second spring, so I'm going to make it C2. And I'll make this lowercase just to be consistent. If you have your arrow on top of different things, so if our damper was our inertia was up here, we wouldn't want our M to be here, so you can just right click, show name, and then change it to left or something like that. For now, I'll just put it back the way it was. So we've actually done quite a bit so far. Now what we need to do is tell 20sim what the values of these things are. So to do that, you can right click and then go to parameters. Just hit yes for model processing now. 20sim needs to do that with each new bond graph. So here we have our value for our mass. We can change it to 2 or 3. I'm going to leave it at 1 because that's what I have in the handout. You have to make sure you hit apply, otherwise 20sim forgets. For our springs, the spring constant was 10, I believe. So what we'll do is we'll change these to 0.1 because it's the inverse for these. You can also click up here, and this will give you a whole list of all the parameters for the model, and then you can click down in as you like. The next thing we'll want to do is set our initial condition. So this is the initial velocity on our mass. So we'll go to parameters again, click on initial values, and our initial state is 0. Let's just make it 5, and remember to hit apply here. So at this point, we're going to skip ahead and just simulate really quickly, and then we'll do some fancier stuff and then go back to simulation. So to get to the simulator, you click this Start Simulator guy up here, and that'll bring this up. What you have to do immediately is go to Plot, and then we're going to go to Variable Name here. We're going to choose a variable name, and there's a whole bunch of them over here, but the best thing to do is to filter by the item. So I want the velocity of the mass, so I'm going to go to this inertia here. Notice how the M label is here. That can make your life a lot easier. And I'm going to pick the state off of this. I could also pick the flow or the effort for this element. So I'm going to hit OK, and then OK again. I'm going to hit play, and this is what the simulation looks like. Let me just double check and make sure my parameters are right. Yeah, okay. Sometimes 20sim messes that up. So here we are. You'll notice our initial condition of 5 is here. And this is how simple plotting is. But there are a few things you might want to do. First off, you might want to be able to get the position of the mass, which we can't get directly. We could get it by adding up the displacements of the springs. That would give us the position, or we could just integrate the velocity, and that's what I'm going to do. And we also might want to put in an input that wasn't constant. Right now we have a constant input, so it's just giving a step function that stays at 1 the whole time, but we can change that around. So I'm going to exit out of the simulator and go back to the bond graph. So the first thing we'll resolve is this position. So go into your library, go to signal, and then click on block diagram. And then you want to find the integrator. There's a bunch of different ones, but we'll just use the plain one. So you drag and drop that on, and then you have to connect it to the inertia. Now notice this arrow is different. Here, these are all bond graph arrows, so this half thing here. This full arrow is indicating that this is a signal. So there's no effort flow thing going on here. It's just running a number to the integrator. Let's rename the integrator to position so we can find it pretty easy later. And now we're going to want to change our input. So this is the constant input block. If you want to have an input that varies, the first thing you need to do is get rid of this and get the MSE block. This one. This is the modulated effort source. And you'll need to reconnect that. And this happened in the lecture. So sometimes if things aren't working, you can just zoom out and then they work. It's magic. I don't know why. But now if you go to your model check, this lets you check and make sure everything's right. What happens is 20sim is upset because it knows it needs a signal going into this block. So we're going to go to our signals and we're going to grab sources, a lot like you would in Simulink. And I'm going to pick this square wave generator. And I'm going to connect this up. And it's upset again. Let's try refreshing. No. There we go. Okay, let me zoom back in so this is a little clearer. So now we have this square wave in. The square wave, you can look at the parameters of again. The model needs to check again because we changed it, so we'll just hit yes. And you'll see there's 0 errors down here, so everything is good. We'll change this to revs per second. So right now it's at 5 hertz with an amplitude of 1. Let's just change this to 5 and this to 1 for kicks. And hit apply. Always hit apply. And now we can bring the simulator back up. But because we closed the simulator earlier, we lost our plot. So remember, if you close the simulator, you're going to lose everything. So make sure to save things or just always keep that window open. I'm going to go through the plot command in a little more detail now. So we'll click on plot over here. There's 3 tabs here. Plot properties is for making the plot look nice. You can set the title, whether you want to show grid, whether you want to log an axis, things like that. The x-axis is time. And we can change the label here. I'm going to change it to time and just throw a little second on there. And now we can go to the y-axis, and I'm actually going to put 3 plots on here. The first one, I'm going to put our input. So if I go through here, we see our little square block. It's got an output. And I'm going to hit OK. And I'm going to label this force. And now I'm going to add another curve. So my next curve is going to be velocity. So I'm going to go to my inertia block like before, click on state, and hit OK. And velocity. And now I'm going to add another curve. This is going to be position. This is the integrator, which we've cleverly named position. You want the output here. The input to this is the velocity. So now hit OK. And we'll label this position. Now we'll hit OK. And now we'll hit play. And that's what the model looks like. Now we can distribute our curves around like this. So this is a lot like subplot in MATLAB. It can make things a little clearer. You can see our square wave input, our velocity here, which has an initial condition of 5, and then our integrator here, which is position. So one thing I actually forgot to do in the lecture was tell you how to change how long this is. So if you go to Properties and Run, you can change your finishing time. So we could run it for 25 seconds. So I'm going to hit OK, and then hit play again. And there's that. Now we're going for a longer time period. You can also change your solver, which I believe you have to do later on. Right now we're using this backward differentiation formula guy. We could use Euler, which won't be very good. I can actually show that. Let me just turn the step size down to half a second. And this ought to not look as good. Yeah, you can see the step over here. Looks like a seesaw, and then clearly the solver is exploding here. We've got this 10 to the 47. That's no good. So I'm going to reset my simulator and go back to our previous one, which was this guy. And we'll simulate again. And there we are. You can change all your parameters again here. So if you wanted to see what would happen if you made your mass 10 times heavier, you can change it here, hit apply, and then run again. And notice how there's a faded out line here. This is your previous run, and this new line is your new run. So this sort of concludes the simulation part. I wanted to show you one more trick, which may or may not be useful, depending on what you're doing. I'm going to go back to our original bond graph. So I'm going to get rid of this modulated stuff and put that force back in here. I might as well label it, why not? And we got to connect it. There we go. We can do our model check. 0 errors, 3 independent states. That's good. Now I can do show equations. And this will give you the dynamic equations that it's using to simulate with. So it's got its dynamic equations, the static equation, and it shows what equations it eliminated through algebra. So if you were working on a homework or whatnot, you could figure out the causality or something like this, or double check it. Causality is not hard to figure out anyway, but you can double check it here. And you could look at those equations and see if things lined up and were good. Anyway, so this concludes the tutorial.